You walk into a museum, bronze gears the size of coins, a clay jar from Mesopotamia, an iron pillar exposed to monsoons for 16 centuries. Zero rust. Nobody explains how. The engineering shouldn't exist yet, but it's there, in fragments, in tombs, in ruins across 3 continents. 12 objects that use principles we supposedly discovered centuries or millennia later. Precision gearing, electrochemical reactions, self-healing concrete, aerodynamic lift, corrosion resistance through phosphorus alloys, each one documented, each one tested, each one impossible for its time. So where did the knowledge come from? What did they know that we forgot? And which of these artifacts actually work? This script is researched and factual using sources from MIT's Science Advances journal published January 2023, analyzing Roman concrete microstructure, the Journal of Current Science from IIT Kanpur on Delhi, Iron Pillar Metallurgy, published 2002, Nature Communications, December 2025 on Pompeii construction sites and scientific reports, March 2021, detailing Antikythera, mechanism reconstruction at University College London. Now back to the information. Item 1508 at National Archaeological Museum, Athens. Months later it splits open. Inside are gears, 30 gear wheels, teeth 1 millimeter long, bronze discs the size of coins, precision gearing that shouldn't exist for 1400 years. Front dial showed zodiac calendar and Egyptian calendar. Back dials tracked Metonic cycle, 19-year lunar calendar, and Saros cycle, 223-month eclipse prediction. One gear had 223 teeth. Prime number. Can't simplify. Has to be that exact count. Another had 127 teeth. Pin and slot mechanism modeled lunar motion. Not circular, elliptical. Matching Kepler's second law of planetary motion, 1500 years before Kepler. Planetary period relations from Babylonian astronomy. Venus cycles, Mercury retrograde. Mathematical theories from Plato's Academy. All mechanized. Turn the handle. Crank drives central shaft. Gears, mesh, pointers move across dials. Shows where planets appear in sky when eclipses happen. Which athletic games occur, Olympic cycle included. Jammed within months. Small spacing errors in hand-cut triangular teeth. Cascade through linked gears. Stop motion. The design was brilliant. Conception exceeded manufacturing precision. Gear trains accumulated error. Would cancel subtle astronomical corrections built into the system. Device couldn't maintain accuracy long term, but it proves the knowledge existed. Cicero in De Re, Publica 54 to 51 BCE mentions 2 machines predicting sun, moon, and 5 planet movements. Archimedes wrote manuscript on sphere making. Lost now. Romans describe his devices. Odometer with square teeth failed. Replaced with angled teeth like Antikythera, and it works perfectly. Required expertise built over generations. But when Rome fell, knowledge scattered. Monasteries preserved some texts. Islamic scholars translated Greek mechanics. Byzantine fragments show geared sundial calendar, 6th century CE. Simpler than Antikythera, but proves continuous tradition. Then gap. Not until 14th century do European astronomical clocks appear. 1300-year void. The gears were there, then gone, then reinvented. Number 2, Roman concrete. Year 79 CE. Pompeii construction site. Regio 9 Block 10. Workers mix quicklime with volcanic ash before adding water. Exothermic reaction. Hot mixing. Preserved when Vesuvius erupts, August 24th, 79. Admir Masick at MIT studied materials. December 2025. Constructed walls. Uncompleted walls under construction. Adjacent dry material piles. Shows unequivocally quicklime was premixed with dry pozzolan before water addition. Creates lime clasts, white calcium chunks, millimeter scale. Previously thought poor quality control. Masick proved they're functional. Self-healing mechanism. Still carries water to Rome today. Modern concrete crumbles in decades. Roman concrete strengthens with time. The secret is in the chemistry. Volcanic ash from Pozzuoli on Bay of Naples. Pozzolana, shipped across empire. Mixed with lime and seawater in ports. Added to aggregate rock, ceramic, and brick rubble. Vitruvius, writing 25 BCE, recommended 1 part lime to 3 parts pozzolana for buildings, 1:2 ratio for underwater work. Harbor at Caesarea, 22 to 15 BCE. King Herod, 35,000 cubic meters of concrete, 24,000 cubic meters pure pozzolana, 52,000 tons of imported volcanic ash, 100 to 150 boatloads from Italy to Judea. Ships returning from Alexandria after delivering wheat carried ash as ballast. The concrete reacts with seawater, forms aluminum tobermorite crystals, rare mineral, grows through composition over time, reinforces structure, prevents cracks. Marie Jackson at University of Utah analyzed Portus Casanis Pier cores 2017. Seawater triggers pozzolanic reaction. Crystals fill gaps. Creates internal reinforcement. Ran water through cracks. Ancient formula samples healed completely in 2 weeks. Water stopped flowing. Modern samples without quicklime never healed. Water kept flowing. The lime clasts have brittle structure from hot mixing. Cracks preferentially travel through high surface area clasts, react with water, create calcium saturated solution, recrystallizes as calcium carbonate, fills cracks spontaneously, or reacts with remaining pozzolanic material, forms more calcium aluminum silicate hydrate, further strengthens composite, automatic, no human intervention. Better long-term performance. At Caesarea, the concrete interfaces with volcanic aggregates show remodeling. Calcium ions from dissolved lime clasts diffuse outward, remineralize at aggregate matrix boundary, produce amorphous phases, multiple polymorphs of calcium carbonate including calcite and aragonite, composite matrix of vesicle filling and pore filling phases, complex crystallization. This is post-pozzolanic reactivity. Works over centuries, gradually reinforces concrete by forming stable mineral phases at interfaces, fills voids, reduces permeability, maintains structural integrity. Potential for sustainable construction today. MIT working to commercialize modified cement formulas based on Roman technique. Could extend service life of infrastructure. Reduce material use. Lower carbon footprint. 7.2, 1 meters tall, 41 centimeter diameter, weighs 6,000 kilograms. Forge welded from pieces of wrought iron. 40 to 50 pound blooms hammered together at high temperature. Capital constructed from 7 individual parts. Fitted over hollow cylinder inserted into pillar body. Moved to Delhi 13th century. Sultan Iltutmish when he sacked Vidisha, or earlier, Anangpal Tomar 11th century to Lalkot Temple. Now stands at Kutba complex in Merauli. The iron has 1% phosphorus. Modern iron has under 0.05% phosphorus. High phosphorus content creates protective layer called misowite. Iron oxyhydroxide, phosphate. Forms barrier at metal rust interface. Adheres next to boundary between iron and corrosion. 0.05% manganese, 0.05% nickel, 0.05% silicon, 0.03% copper, 0.02% nitrogen, 0.005% sulfur. The phosphorus is key. Converts unstable iron, oxyhydroxides in rust layer to stable compounds. Transforms into magnetite layer. Phosphoric acid reacts with iron. Forms crystalline iron hydrogen phosphate hydrate on surface. This compound provides excellent corrosion resistance. Alternate wetting and drying cycles help form protective passive layer. Delhi's relatively dry atmosphere aids process. Understanding iron behavior at various heating stages, deep empirical knowledge. Ancient Indian metallurgists used direct reduction method. Extract iron from ore without liquefying. Results in purer iron with controlled phosphorus from specific ore selections. Balasubramanian theorized they deliberately chose high phosphorus ores. New connection between phosphorus content and rust resistance. Similar properties found in other ancient Indian iron objects. Pillars at Dar, Mandu, Mount Abu, Kodachadri Hill. Iron cannons from medieval period demonstrates widespread metallurgical expertise, not isolated achievement, systematic knowledge across regions. Some scientists propose alternative theory. Soil rich in beneficial bacteria surrounds pillar base. Microorganisms form biofilms, shield iron from corrosive agents. But phosphorus mechanism has stronger evidence. Inscription on pillar in Sanskrit, Gupta script, 6 lines, 3 stanzas. Names King Chandra, confirms Chandragupta II, dates between 375 and 415 CE. Paleographic analysis matches dated inscriptions from Udayagiri. The writing well preserved because corrosion-resistant iron protects engraved surface, though some letters imperfect where iron closed over strokes during engraving. UNESCO World Heritage Site status since complex includes Qutb Minar. Conservation balances preservation with public access. The pillar remains accessible but untouchable. Symbol of ancient scientific achievement visible to 21st century eyes. Capital of Parthian Empire, 150 BCE to 223 CE, and Sasanian Empire, 224 to 650 CE. Found 1936 during excavations. Wilhelm Koenig, Director National Museum of Iraq Laboratory. Ceramic pot, copper cylinder, iron rod, all fixed with bitumen seal. Height 14 centimeters, copper tube rolled from sheet, iron rod centered within copper. Asphalt stopper insulates metals from each other. Koenig published 1938. Proposed galvanic cell, possibly used for electroplating or electrotherapy. No electroplated objects found from period that can be definitively confirmed as electroplated. Objects Koenig saw in 1938 now believed fire gilded using mercury. Not electroplated. No wires found. No written records of such devices. Asphalt seal would need breaking every time electrolyte replenished. Produced 4.33 volts. Visibly electroplated small copper token with zinc overnight. 5 jars sufficient for painful current through acupuncture needles. 10 jars insufficient for shock to dry skin. Archaeologist Ken Feder noted no evidence for connections between jars or use for electroplating. Willard Gray, after World War II, showed grape juice in reconstruction produced current. Arne Egebrecht, 1978, claimed electroplating gold onto small statue using Baghdad battery reproduction. No photographic or written records of procedure exist. Scientific community remains skeptical. Many Mesopotamian items had spiritual significance. Ability to produce slight tingle might seem divine power. Medical use possible. Paul Kaiser, Journal of Near Eastern Studies, 1993, suggested ancient batteries and electric eels for pain relief or anesthesia. Bronze and iron needles found alongside jars at Seleucia. Could be acupuncture tools. Greeks and Romans used electric fish. Torpedo rays. Scribonius Largus, 1st century CE, prescribed black torpedo fish under feet for gout. Place fish where sea washes over it. Numb affected area up to knees. Electrical therapy documented in multiple ancient cultures. Intended for that purpose? No conclusive evidence. More likely storage or ceremonial function. Coincidental design produces small voltage. It doesn't prove technological application, but possibility can't be entirely dismissed. Bronze water screws cast in Assyria, 7th century BCE under King Sennacherib. Stephanie Daly argued from cuneiform inscriptions, used for hanging gardens of Babylon irrigation. Advanced hydraulic engineering existed. Small step from mechanical to electrochemical understanding. Knowledge could have existed without leaving archaeological record. Come January 2025, on Antikythera mechanism simulation failures, science advances. January 6th, 2023, on Roman concrete hot mixing chemistry by MIT and Harvard researchers, and American mineralogist, July 2017, on Roman seawater concrete from University of Utah, geological analysis. Now back to the information. Excavated 1898, sycamore wood, wingspan 18 centimeters, weight 39 grams, resembles streamlined bird or small aircraft. Housed Egyptian Museum, Cairo, classified as cult object. Falcon representation, Horus deity, Ra sun god. But features seem unusual. No carved feathers, no feet, vertical tail fin. Birds have horizontal tails. This one, vertical like modern airplane stabilizer. Flight enthusiast, member Egyptian Aeronautical Club. Noticed artifact at museum. Published African Experimental Aeronautics, a 2,000-year-old model glider, 1991. Claims wing made one-piece wood, span exactly 18 centimeters, body thickest part 8 millimeters. Tapers toward tips, dihedral angle, slightly unequal both sides due wood distortion over time. Dihedral angle, same principle, modern aircraft, used for lift. How does 2,200-year-old object incorporate aerodynamic characteristics? Coincidence or knowledge? History Channel commissioned replica without tailplane. Wind tunnel test, produced 4 times gliders on weight and lift, without tail stabilizer, held in position by cables for stability. Data taken to Liverpool University. Added tailplane in flight simulator, tested under conditions mimicking ancient Egypt airstreams and desert environment. Model flew quite well in simulation. Over 2,000 years after creation, if Egyptians built aircraft based on design, it would have flown. Mainstream archaeologists don't see evidence of aerodynamic knowledge, but Saqqara artifact differs from other Egyptian bird figurines, possesses characteristics never found on birds, yet part of modern aircraft design, as Messiha noted. Ancient Egyptians made boomerangs. Wooden throwing sticks curve precisely. Understanding aerodynamics and air mechanics required for boomerang function. If they knew boomerang principles, could they know other flight principles? 3 papyrus found near artifact. One allegedly mentioned phrase, "I want to fly." Hieroglyphs on model read, "Gift of Ammon." Sycamore wood, sacred to goddess Hathor, symbol of immortality. Heavy wood. If model represents prototype, maybe real version, used lighter wood, untested theory. 2 possibilities. Pure coincidence, bird-shaped object naturally somewhat aerodynamic, or deliberate design based on observation and experimentation. Without additional evidence, question stays open. The artifact exists. The tests show it could produce lift with modifications. Whether ancient Egyptians intended flight remains speculation. Attributed to Archimedes of Syracuse, 287 to 212 BCE. But evidence suggests earlier origins. Assyrian king Sennacherib, 704 to 681 BCE. Cuneiform inscription describes casting bronze water screws 350 years before Archimedes. Consistent with Strabo's writings, hanging gardens of Babylon irrigated by screws. Ancient Egyptians used screw pumps to lift water from Nile before 3rd century BCE. Tubes wound round cylinder, entire unit rotates, water lifted upward. Believed Archimedes invented during Egypt visit around 234 BCE. May reflect apparatus unknown to Greeks before Hellenistic times. Archimedes improved design, made it more efficient. King Hiero commissioned largest ship possible. Ship proved leaky. Archimedes invented device to remove water. One person could operate it. Prevented sinking. As screw rotates, creates pockets where water trapped. Tubing curves upward both sides. Pockets move up. Screw to upper container. Alternating pockets of air and water. If angle too steep, water flows back down. Standpipe vertically. No trapping occurs. Water falls. Optimal angle around 45 degrees. Efficiency depends on pitch, angle rotation speed, and seal between screw and housing. Modern versions, 70% efficient. Used in ancient world for irrigation, lift water from rivers into fields, remove water from mines, protect miners from drowning. Egyptians used it extensively. Romans adopted technology, spread across empire. Vitruvius described construction in De Architectura, 1st century BCE. Specifications for materials and dimensions, medieval period technology preserved. Renaissance reintroduced across Europe. China and Japan adopted screw pumps through trade routes. Water fed into top forces, screw to rotate. Rotating shaft drives electric generator. Archimedes, screw turbines in use on River Thames. Power feeds Windsor Castle. Efficient in low head sites. Wide range of flows and moderate heads. Ideal where traditional turbines don't work well. Low rotation speed, fish friendly. Aquatic life passes through safely. Renewable energy source. Continuous use for over 2,000 years. Simple machine, inclined plane wrapped around cylinder. Basic physics, elegant solution. Proves ancient engineering focused on practical problems. Understood mechanical advantage. Leverage, fluid dynamics, created lasting technology. No electricity needed. Human or animal or wind or water power. Sustainable, adaptable. Scale from small hand cranked versions to massive installations, moving thousands of gallons per minute. Universal tool. Siege of Constantinople, 674 to 678 CE. Arab fleet destroyed. Weapon decisive in Byzantine victory. Formula closely guarded secret. Known only to imperial family and select craftsmen. Hanna Komnene, 12th century, described it as liquid fire hurled through tubes. Produced roaring sound, dense smoke, flames like lightning. Modern analysis suggests petroleum-based. Naphtha or crude oil mixed with resins, pine resin, quicklime for ignition. Sulfur and saltpeter possible. Pressurized through bronze tubes, pump mechanism, siphon system heated mixture. Atomized spray ignited as it left nozzle. Manufacturing secrets died with empire. Attempts at recreation based on descriptions. Combination of naphtha resins, sulfur and oxidizers most likely. Similar to napalm in behavior, sticks to surfaces, burns intensely. Water spreads flames rather than extinguishing. Matches historical accounts. Gave Byzantines technological edge for 4 centuries. Eventually lost. Knowledge fragmented. Empire declined. Military technology moved to gunpowder weapons. Greek fire obsolete by 14th century. Some historians question effectiveness, suggest psychological impact exceeded actual destruction. Others argue decisive weapon in key battles, preserved Byzantine power against Arab expansion. Liquid fuel delivery, pressurized projection, heat resistance in bronze components, sophisticated metallurgy for siphon construction, integration of chemistry and mechanics, military application of scientific knowledge. Byzantines maintained edge through innovation, and when formula lost, technology died. Couldn't be reconstructed from descriptions alone. Precise ratios mattered, processing methods critical. Knowledge requires practice and transmission. Once chain-broken recovery impossible. Made from steel ingots called woots. High carbon content 1 to 2%. Trace elements including vanadium, chromium, molybdenum, manganese. Smelted in crucibles. Precise temperature control. Slow cooling creates microscopic carbide structures. Dimensions 1 to 50 nanometers. These reinforce steel matrix. Provide strength and flexibility. Cutting edge stays sharp because carbide's hard. Main body flexible because ferrite matrix. Combination gives superior performance. Ancient metallurgists achieved nanoscale engineering without microscopes. Empirical knowledge. Trial and error over generations. Used woot steel. Forged blades. Got banding pattern, but not full Damascus characteristics. Missing trace elements. Peter Poffler, 2006, found cementite nanowires and carbon nanotubes. Formed during forging from vanadium and other impurities. Modern steel lacks these elements, can't produce same structure with different chemistry. When high manganese sources depleted, quality dropped. Forging knowledge couldn't compensate for material differences. Last known Damascus blades, made mid-18th century. After that, attempts failed. Modern recreations approximate appearance. Acid etching creates banding, but internal structure different. True Damascus steel requires specific ore chemistry and precise forging techniques. Both together. Either alone, insufficient. Islamic Golden Age preserved and advanced metallurgical knowledge. Translated Greek and Indian texts. Conducted experiments, built on previous work. Damascus became center of sword production. Imported woots ingots. applied forging expertise, created weapons superior to anything in medieval Europe. Crusaders encountered Damascus blades in battle, described cutting power with awe. European attempts to copy failed. Didn't have access to Wootz steel. Didn't know carbide formation process. Technology remained Middle Eastern monopoly. When lost, it stayed lost. Until electron microscopy revealed nanostructure, modern science couldn't intentionally create at that scale. Ancient craftsmen did it routinely. Knowledge encoded in practice, not theory. When practice stopped, knowledge vanished. British Museum. Appears green in reflected light. Glows red when light shines through. Only Roman glass object showing this property. Made using colloidal gold and silver nanoparticles. 50 to 100 nanometers diameter. Suspended in glass matrix. Surface plasmon resonance creates color change. Gold nanoparticles absorb and scatter light differently depending on illumination angle. Found gold-silver ratio about 7:3. Particle size precisely controlled. Too large or small effect disappears. Romans achieved nanoparticle engineering. Didn't know atomic theory, didn't have electron microscopes, yet created controlled nanostructure. Empirical process. Adding gold salt to molten glass. Precise heat treatment. Results in optimal particle size distribution. Why only one known example? Extremely difficult to produce. Required perfect conditions, temperature, timing, composition ratios. Small variation ruins effect. Most attempts probably failed. This one succeeded, preserved because rare and valuable. Interacts with embedded nanoparticles. Creates dichroic effect. Combination of artistic skill and material science, both at highest level. Scientists now study it for optical applications. Sensors, display technologies, bioimaging, surface plasmon resonance effect at nanoscale. Romans used it decoratively, didn't understand mechanism, but controlled process well enough to produce it. A single successful example proves capability. Knowledge must have existed. Why not more examples? Possibly economics. Gold expensive. Process difficult. Success rate low. Few attempts made. Even fewer survived. This one made it. Shows what Roman craftsmen could do at their peak. So designers approximated. Used simpler ratios. 365 divided by 223. Close enough for practical prediction. Error accumulates, but acceptable over years. Shows understanding of trade-offs. Precision versus manufacturability. Ancient Greeks didn't know heliocentric model. Used epicycles. Small circles on larger circles. Geocentric model worked mathematically. Could predict positions accurately. Antikythera mechanism implements epicyclic theory. Gears within gears. Planet position calculated by compound rotations. Mercury, Venus, Mars, Jupiter, Saturn. All 5 known planets, plus Sun and Moon. 7 celestial bodies tracked. Each requires separate gear train. All intermeshed on same frame. Outputs displayed on front dial in cosmological order. Subdivided into cells. Each cell represents 1 month in cycle. Pointer moves through cells as you turn handle. When pointer reaches, filled cell, eclipse predicted. Type specified by inscriptions. Lunar or solar. Partial or total. Time of day. Magnitude. Small error, but good enough for calendar keeping. Greeks used Metonic cycle since 5th century BCE. Meton of Athens discovered relationship 432 BCE. Antikythera mechanism automates calculation. Turn handle. Watch pointer advance. When completes 19 revolutions on solar calendar dial, Metonic pointer. Completes full circle. Calendar syncs. Reset and repeat. Ancient Olympics plus other Pan-Hellenic games. Pythian, Nemean, Isthmian. Mechanism shows which games occur which year. Cultural calendar embedded in astronomical device. Links cosmos to human activities. Sports festivals timed by celestial cycles. Everything connected through mathematical relationships. Implementing those models in gear ratios. Optimizing for available tooth counts. Managing cumulative error. Designing user interface. Making complex calculations accessible by turning handle. This is software written in bronze. Algorithm expressed in mechanical form. Before computers, before calculators, before printed tables. Ancient Greeks automated mathematical astronomy, didn't need electricity, didn't need Arabic numerals, used what they had. Metal, geometry, ingenuity. Construction simple. Bronze sphere. 2 hollow tubes as bearings. Mounted over heated water source. Steam pressure builds. Escapes through nozzles. Thrust rotates sphere. Continuous rotation as long as water boils. Hero understood principle. Called it pneumatic device. Studied compressed air and steam. Wrote treatises on mechanical devices. Temple door openers. Automatic wine dispensers. Vending machines. Water organs. Fire pumps. Self-trimming oil lamps. Applied pneumatics extensively. Rome had engineering knowledge. Used it differently. Prioritized aqueducts, roads, bridges, buildings. Water distribution. Infrastructure. Not mechanical power. Thomas Newcomen. 1712. Atmospheric engine. Practical mine pumping. James Watt. 1769. Separate condenser. Efficient design. Industrial Revolution begins 1800 years after Hero. Knowledge existed, application waited. Economic and social conditions had to align. Rotation for momentum change. Hero demonstrated concept, explained theory, created working model, just didn't build industrial machines, because context didn't require them. Ancient world solved problems differently, used knowledge available, adapted to circumstances. Technology develops when needed, not just when possible. Ground from rock crystal, slightly oval, 42 millimeters by 45 millimeters, thickness 5 millimeters at center. One face convex, one face flat, polished, smooth, magnification about 3 times, focal length 11 centimeters. Could focus sunlight to start fires or magnify objects. Giovanni Pettinato. 1978 proposed its oldest known lens, used for magnification, supporting evidence from cuneiform texts. Describe optical effects, seeing small things made large. Assyrian craftsmen worked microscopic detail, cylinder seals, carved gems, intricate intaglios. Needed magnification to produce. Lens would help. Other similar objects found. Unclear if lenses or decorative glass. David Brewster examined 1852. Confirmed optical properties could be used for vision correction or magnification. But skeptics argue accidental shape, not designed as lens. Natural crystal, polished, smooth, happens to magnify. Coincidence? Not intention. No evidence. Assyrians understood optics theoretically. Counter-argument, practical knowledge. Don't need theory to use lenses. Trial and error. Observe magnification. Use it. Manufacture more. Empirical tradition. Ancient craftsmen worked by doing, not explaining. Whether Nimrud lens represents that knowledge remains debated. Physical evidence present. Clear optical function. Purpose uncertain. Manufacturing intentional or accidental unclear. Can make tools without fully understanding them. Knowledge encoded in technique, passed through demonstration, not written explanation. When technique lost, tool becomes mysterious. Nimrud lens might be oldest optical device, or might be polished rock that happens to magnify. Either way demonstrates ancient materials. Technology, crystal working, grinding, polishing, precision shaping, skills existed. Application varied. Here's what ties them together. Engineering principles discovered by trial, not theory. Knowledge preserved in objects, not equations. Transmission through apprenticeship, not documentation. When manufacturing stopped, knowledge vanished. Couldn't reconstruct from finished products alone. Required practice and experience. Some technologies rediscovered, others lost permanently. The artifacts prove ancient craftsmen understood materials, stress, forces, reactions. Applied understanding practically. Created tools that worked. Not always sure why they worked, but they did. Each investigation answers some questions, raises others. How did they achieve this without modern instruments? How much did they understand versus how much was empirical? Where did knowledge come from originally? Why did some technologies persist, others disappear? Proves hot mixing technique. Quicklime premixed with pozzolan before water. Creates self-healing properties. MIT reconstruction tests confirmed. Ancient method works. Modern concrete should adopt it. Environmental benefits. Longer service life. Less maintenance. Lower emissions. Roman knowledge applicable today. Studied seriously 20th century. Mechanism finally understood 21st century. Gap from practice to comprehension nearly 2 millennia. Similar gaps throughout history. Ancient knowledge lost, partially recovered, some still missing. Damascus, steel composition known now. Forging sequence uncertain. Can approximate, not duplicate. Greek fire chemical analysis suggests components. Exact ratios unknown. Processing steps unclear. Some secrets stay buried. What could we be making now that future won't understand? Semiconductor fabrication, nanometer precision, billions of transistors. Future archaeologist finds chip. No documentation. How manufactured? Why this pattern? What purpose? Modern supply chains fragile. Specialized knowledge concentrated. If disrupted, how long to recover? Months? Years? Decades? Some ancient technologies took centuries or millennia to rediscover, or never came back. The Antikythera mechanism sits in museum, fragmented, corroded, 82 pieces. Scientists reconstruct digitally, print replicas, test hypotheses, still debating details. 2,000 years of study, not finished. Meanwhile, some worker in Rhodes or Athens around 100 BCE turned handle, read predictions, used device daily, knew exactly how it worked. That knowledge died with them. We're still catching up. In Pompeii excavation, December 2025, researchers found construction materials exactly as workers left them August 2479 CE. Quicklime pile, volcanic ash pile, unfinished walls showing hot mixing technique. 2,000-year-old evidence confirming what Vitruvius got wrong and MIT got right in 2023. Ancient practice preserved in frozen moment. Modern science validates ancient method. Brings tradition back. But 1600-year gap in between. Knowledge could have continued. Instead, it stopped, restarted elsewhere. Some never restarted, building on previous work, continuous improvement. But history shows otherwise. Knowledge comes and goes. Civilizations rise and fall, techniques develop and disappear. Survival isn't guaranteed. Transmission requires active effort. When effort stops, knowledge stops. Objects remain, waiting to be understood again.